Okay, here we go. I've all lost track of what I'm doing now. 3.5 is where we're headed today. So, looks like we have 17 problems to cover. So we're going to probably move past our 30-minute window limit, but you guys are going to have to suck this one up. So, here we go. Anyway, number one, we're going to be given a function r of x is equal to 12x over x minus 13. And we are again asked for the domain restriction. Again, a domain restriction is created when either we have a 0 in my denominator or I'm trying to take the square root of the negative number. This has a 0 in the denominator. I know that x minus 13 cannot be equal to 0. So that means that x cannot be equal to 13. I will have a domain restriction there. Okay? And all it's asking me for is what that domain restriction is. I'll back up. It's actually asking me for the domain now that I actually read the problem. That always helps. Okay. It wants me to find the domain of the following rational function. So that means my domain, actually no. So it is written as all real numbers except x cannot be equal to 13. So it's going to look like that. A little bit different form than we're used to. It's not asking me to write an interval notation. We're looking for just dropping the 13 into that blank. Okay, so let's try the next one. Number 2. Again, it's asking me for the domain. That's going to be x plus 10 all over x squared minus 10. Excuse me, x squared minus 100. As we go to look at this one, I'll leave the numerator there for now, x plus 10. I'm going to factor this denominator because in order to solve that, it has to be in factored form. So that's going to be the perfect squares. So it's x plus 10 and x minus 10. And so now we're going to go ahead and find the domain restrictions now. So I have a domain restriction here of negative 10 because that causes that parenthesis to go to 0. 10 is going to take that one out. So that means that we're going to eliminate negative 10 and 10. So we're going to take those out. We'll just separate those by commas. So it's going to have the same notation as the problem above it. X cannot be equal to negative 10 and 10. I'm going to extend this problem just a little bit because what's going to happen, and because it's just a nice example, what's going to happen is we're going to be starting to graph rational functions. And what we're going to see is we have domain restrictions are going to be vertical asymptotes or they're going to be discontinuities or holes. Okay, which means I'm going to have, there's a spot in the graph. It doesn't count as an asymptote, but it is going to count as a discontinuity. So what happens is those are going to cancel out. And so my final expression simplifies into 1 over x minus 10. So I can see I'm still going to have a vertical asymptote at 10. However, negative 10 is also going to be included that, but when we see a graph of that, we would see a hole at negative 10, just a spot where that graph doesn't exist. It's not going to be an asymptote where the function is going to approach the asymptote but not cross. Okay? So again, you don't have to know that now or for that problem, but down the road we're going to see that. Okay? Again, this is all about domains. 14x squared plus x all over x squared plus 10. So again, domains, we're only focused on my denominator. We're talking about x squared plus 10. We know that x squared plus 10 cannot equal to 0. So we're actually going to look at this one a different way. We're going to get x squared is equal to a negative 10. And when I square root both sides, I get plus or minus I radical 10. So my my asymptotes are actually imaginary. So this is going to be one where there are no restrictions. There is no real number that is going to cause my denominator to hit a 0. So we can just stop there. Mark no restrictions, move on. Okay, let's hit number 4. Find the asymptotes, if any, and the values the corresponding to holes, if any, of the graph of the function. So we are given this function. F of x is equal to x over x plus 2. And it's a little hard to see. Maybe I can just throw it over here. It'd probably be a horrible glare, but we'll try. There we go. You could think I would be more tech savvy than find something else. But anyway, here we go. We see we have 4 options. The vertical asymptotes are with no holes, or there's vertical asymptotes, no vertical asymptotes, but holes. And so we have the different combinations of those. Or lastly, there's no discontinuities. So, again, going back to my asymptotes, we're worried about x plus 2. X plus 2 cannot be equal to 0, so that means that x cannot be equal to negative 2. Okay, so that means we're going to have an asymptote. How's that going to be? it is just going to be type an equation. So that means that x cannot be negative 2. Okay? Or it could be, this may not be there. It may be x equals negative 2. We'll see. And that's my only discontinuity here. If something cancels out, that creates a hole. In this case, nothing cancels out, so we're just left with a single asymptote at negative 2. All right, 5, and moving on. We have this function, h of x is equal to x plus 3 all over x times x minus 3. And again, we're only worried about that denominator. X times x minus 3 cannot be equal to 0. So that means that x cannot be 0, x cannot be 3, because those are the two values that cause that whole thing to go to 0. Those both, since nothing cancels, this is x plus 3 and x minus 3, nothing cancels, so those are both asymptotes. So we're going to have asymptotes at x cannot equal 0, x cannot equal 3. All right. Keep it on, keep it on. Number 6. F of x is equal to x over x squared plus 19. And again, we're worried about x squared plus 19. That cannot equal 0. X squared cannot equal negative 19. We're going to be stuck with that darn imaginary number again. So that means that here there are no restrictions, or in this case, no discontinuities. Okay? Forgot that washes out when we move it on up, so we'll put a pad in there. All right, so now we're talking about 7. Still talking about vertical asymptotes and holes. So we have, again, this is going to be predicated on your ability to factor. F times f of x is equal to, we have x minus 1 is over x squared minus 4x plus 3. So I'm going to factor, here we have, and this one I'm going to leave factor. I'll leave it in its fraction form. We need to factor this. So that's going to factor into x and x. We need factors of 3 that add to give us negative 4. Well, negative 3 and negative 1 are going to do that. So this has actually both kinds sitting right here, because what's going to happen is those x minus 1s cancel. So that means that this is a 3 and this is a 1. We're going to have an asymptote at x equals 3. We're going to have a hole at x equals 1. Okay? Because again, when we look at a graph of that, when we get to the graphing part, it's going to have an asymptote versus a hole. So I should be more organized than I am, but you're going to have to just live with that. So let's quickly type this into my calculator and see what we get. So we get x minus 1. Oh, no bueno. Try again. X minus 1 divided by x squared minus 4x plus 3. And we're going to zoom 6. All right, so if we can look at this, surely we can zoom in. I'm not jacking this up too bad. So there's my graph, okay? We can see at 1, 2, and 3, there was a vertical asymptote because my line is gradually going to approach that. Now we had another critical value, and that was at 1. So if we zoom in, looks like my calculator went right through there. Anyway, we're going to zoom out now, which is what, 3? Oops, clear, it's tough. I don't know what I'm doing. Okay, let's go look at the table real fast. We can see in my table that at 3 we got an error, so that's going to mean that that's at my vertical, that's my, no, yeah, 3 was the vertical asymptote. We also got an error at 1, so that's the hole. That actually isn't going to show up in my calculator graph, it's going to go right through that, but we have to be able to indicate that on a graph. Okay? All right, let's see what 8 holds for us so we can keep on moving the chain. Find the horizontal asymptote. All right, so I feel like starting a new page for horizontal asymptotes. So that's what we're going to do. All right, here it is. 8 horizontal asymptotes. 10x over 9x squared plus 1. So coming back to my graph here, I'm going to zoom and we're going to 6. So what happens here is a horizontal and vertical asymptote. So here we have a vertical asymptote. Okay, it goes up and down. I don't want to mark the pen on my screen. What am I doing? Okay, we can look as x gets really large. Like this is x is equal to 10, but what happens when x goes clear out here to 1,000,000? Or we go clear to the left to negative 1,000,000, that's what we have to be able to figure out. And I didn't realize that I hadn't zoomed back out, so that would be the in, we need the out. All right, so we are trying to find out what happens when x gets really big. So we can remember rules if we want to, or we can plug in values. This is completely up to you on how you get this done. Okay, so no, I'll just go through it the cheap and easy way. I'm going to take 10,000 and I'm going to put that in for x. So I'm going to type this into my calculator real fast. So we've got 1, and then we got 4, 1, 2, 3, 4, 5. 10 times 10,000 gives me 100,000. Divided by 9 times, oops, we need the parenthesis in here because we're going to have a denominator. 9 times 10,000 squared. Close that off. Plus 1. No, we're not going to close it off. Man, I'm going to botch this yet. There we go, and we get a number that's 1.11, but it's times 10 to the negative 4th. So this is 0.0001, which is a number that's really close to 0. So this is just like the one that we showed you. This one's going to have a horizontal asymptote at 0. Okay? Now, we can actually remember rules if you'd rather remember rules. So let's talk about our rules real fast. Okay? In this case, we have a degree of my numerator is 1, the degree of my denominator is 2, and all has reference to the degrees of my numerator and denominator. Okay? So rule number 1, degree of denominator is larger. Okay? Which is the exact situation we have right here. We have a 1 on top and we have a 2 on the bottom. And if we think about this logically, my x value on top is getting taken to the first power. The x on the bottom is being squared. So therefore, my bottom is becoming a much, much larger number compared to my top. Okay? And we all know what happens when my bottom starts getting larger. Okay? We have to get new pants. Just kidding. As my bottom continues to grow, that means my number is going to gradually get closer and closer and closer to 0. Okay? So that is why, with the bottom increasing faster than the top, we're going to always go to y equals 0. So that's pretty easy. If the bottom is larger, it goes to y equals 0. Okay? Let's go to number 2. Okay? I'll go and look at the next problem and see if it's in right. Number 2, okay, is actually for number 9. Okay? So I'm going to slip down to here to talk about number 9. And then we'll go back and fill in the rule in just a second. We have 10x squared all over 5x squared plus 7. Okay? And again, if we get stuck on these and forget your rules, we can use a really large number. So here we go. We're going to go with 10,000 again. So 10 times 10,000 squared all over 5 times 10,000 squared plus 7. 10 times 10,000 squared equals, we're going to divide that by 5 times 10,000 squared plus 7. And we get a number that's really, really close to 1.999999972, which is really close to 2. Okay? Now let's think about this. If I looked at 10 and 5, what is 10 divided by 5? That is 2. That is because my numerator is being squared, my denominator is being squared, and when I get really, 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 literally large, this plus 7 makes 0 difference. So therefore, when the degree are the same, y equals the ratio, not ration, oh my gosh, ratio of leading coefficients. Okay, so I have a rule if a rule helps, or I'm just going to go with a really large number. All of them work. Now 3. So we got the denominator is larger degree, we got them equal, and so now degree of numerator is larger. And this creates a slant asymptote. And we will get to a slant asymptote later on in the section. So we're going to skip that for now. So for right now, it's only going to be working on these and this one and this one. Those are the only 2 rules that we're going to see. Okay? So now let's jump on to number 10 and see what it's asking us to do. Find the slant asymptote, if any, and graph the rational function. So now let's look at actually this is our 3rd one. I'm not going to write it down. I'm just going to hold my iPad over here and we're going to look. We got 16x cubed and 6x squared plus 7. I'll write it down. Okay. Now in this case though, going back to this one, the degree of my numerator is larger. So here the degree of my numerator is larger, and I said that it has to go to a slant asymptote. So we see here that my choices are the horizontal asymptote is blank. That's not applicable. There is no horizontal asymptote. True, because it now becomes a slant asymptote. So this is going to be option B. Okay. Rolling through our slant asymptotes. Sometime in here, they're going to start asking us to graph, and then we're going to have to really work with it. All right, so moving on, and here it is. It is number 11 is where we start this process at. And number 11 is a 7-part problem, and your hearts all skip a beat because you all love these. Okay. All right, so 6x over x plus x minus 4. Okay. One thing is, you have the advantage. You could type that into your calculator, look at the graph, see what you get. But we could talk about it in general if you want, which is what we're going to do. We're going to talk about the rules specifically. So the first one's all about symmetry. Remember, in symmetry, we're going to evaluate f of negative x, and we're going to see what happens. So I have 6 times negative x all over negative x minus 4, which gives me a negative 6x all over negative x minus 4. So what happens is everything is negative, so that means all those negatives cancel out. So we end up with 6x over x plus 4. My original was 6x over x minus 4, so that means that I have one stay the same and one change, so this one has no symmetry if we're following the book. Okay, so I'm going to go through all the parts to this on the first one just to make sure I'm going to do all the parts. There's no y-axis symmetry. Are you sure? Okay, I guess I got to hit the right button. Okay, what is our y-intercept? So this is part A. Or actually, this is question 1, my bad. Question 2. Again, what is the y-intercept? And again, at the y-intercept, we know that the x-coordinate is 0. So I'm going to have a 6 times a 0 over a 0 minus 4. And we're going to end up with 0 divided by negative 4, which is just going to be 0. Okay? Now, when we graph these, I'm going to come out here and make a little note out to the side. The y-intercept is going to be the ratio of constants. Okay, so let's talk about a completely different one. So I'm going to pull on another piece of paper here. Maybe. So if I was looking at x squared plus 7x plus 2, and we were doing that as, actually we're going to make that a 4, and we talk about x squared minus 3x minus plus 2. I don't care what it is. We're just trying to find the y-intercept. And we said the y-intercept, this is going to go to 0, this is going to go to 0, this is going to go to 0, and this is going to go to 0 because we're putting a 0 in for x. So the only thing I'm left with is 4 and 2. So that means this one has a y-intercept at 2. And again, I'm not worried about on that problem. I was just trying to show you that your y-intercepts, because your x value all disappear, is just going to be the ratio of constants. If we go back to this problem, my constant in my numerator is 0. The constant in the denominator is -4. 0 divided by -4 is 0. And that's actually what we did here. 0 over -4 is just 0. So my y-intercept is 0. Okay? And it wants us to type an integer there. So we'll type in a 0. And we got that right. Okay? So step number 3. What are your x-intercepts? Okay? All right, so on your x-intercepts, remember that this is going to be f of x is equal to some function. F of x is the same thing as y, so we're going to put, and I didn't do a very good job here. So again, your y-intercept, we know that for the y-intercept, x equals 0. For the x-intercept, we're going to know that y equals 0. Okay, so because the y value equals 0, we're going to have 0 equals 6x over x minus 4. Now, what's your first step in solving this? Well, your first step in solving this is to multiply by x minus 4. X minus 4. So that means I end up with 0 equals 6x. So that means that x is equal to 0. Now, if we think about, let's go back to this guy for a second. Let's see if we can come up with a rule here. I'm going to go back to x squared plus 7x plus 4 all over x squared minus 3x plus 2. And again, those values are completely irrelevant. To find the x-intercepts, we're going to set my function equal to 0 and solve. Well, that means I have to multiply by x squared minus 3x plus 2, x squared minus 3x plus 2, and lo and behold, I end up with x squared plus 7x plus 4 equaling 0, because my denominator ended up disappearing because I took it times 0. So in the grand scheme of things, my denominator does not matter. I could have had a gazillion terms in this polynomial, but I took it all times 0, so it just disappears. So when we go to find that x-intercept, is just found by setting the numerator equal to 0. Okay, that's all we're going to do for that x-intercept. So in this case, we turned out that x was 0 as well. And if it crosses the x-axis at 0, it has to cross the y-axis at 0, and vice versa. So we should be good there. Okay. It says, what are your asymptotes and your vertical? Excuse me. What are the x-coordinates of the vertical asymptotes for this? So again, we're going to go. This is what we did the first half of the section on. We have for step 4 here. Okay. Again, my equation is 6x over x minus 4. My vertical asymptote is going to be x minus 4 cannot be equal to 0. So that means that you can't see that because I got that too far over. But anyway, x is cannot equal 4. So that means that is my vertical asymptote. It says, what is the x coordinate of that? So it's going to be 4. All right. 5. Is asking for our horizontal asymptote. So again, we're left with this function. We're trying to graph 6x over x minus 4. And this falls into my rules. So I can either plug in 10,000 for x and figure out what that is. 60,000 divided by 5,000, 59,996. Anyway, because these are both a degree of 1, that's irrelevant. So it becomes this ratio here, 6 over 1 or just 6. So that means that my horizontal asymptote is going to be y equals 6. So you have to remember those rules, or you have to just use a large number, whatever works. Okay? In step number 6, Excel is wanting you to find points that go on your graph. So in my case, it's giving me -5 and 1 and 5. Okay? It's just asking me to figure out what are those points as far as if I put them into my equation, what would I get? Okay, so if I put a -5 in for x, that's going to give me a -30 divided by -9. Okay, so that's going to give me 13 ninths. I'm going to put 1 in there. So that's going to give me 6 over -4. So -3 halves. And then we're going to put a 5 in there, which is going to give me a 30 divided by 1, which is going to give me a 30. Oh, do I really want to type these points in? I guess I'm going to be forced to. What did I say the first one was? 39ths? Jerk. Boy, working with, oh man. Sorry, this is why I'm feeling sympathetic to you guys right now because I'm trying to type this thing into Excel and it is just being a complete pain in the bottom side. Okay, I hope -3 halves types in easier. Wow. Just what you wanted to do. Log into here, Mr. Dotty, just struggle away on trying to enter something into Excel when you knew that already. It's a pain in the butt. Maybe y'all at home now and can be working on a device that's not. My wife is back here laughing at me. I don't know if you can hear it or not, but she's definitely finding this very funny. Pain. No! I don't care. I'm moving on. Something I didn't like. We're moving on. Dock me points. I don't care. Okay. Here's what you have to be able to do then. We're going to plot what we have. Okay. Here's our graph. We decided that we had a vertical asymptote at 4. So at 1, 2, 3, and 4, we're going to have a vertical asymptote. Okay. We decided we had a horizontal asymptote at 6. So 1, 2, 3, 4, 5, and 6. Here's a vertical asymptote filling across there like that. And now we're left to fill in the gaps. We know we have an x-intercept at 0 and we have a y-intercept at 0. So because of that, I know this graph is going to come and approach the asymptote to the left and to the right. And it's going to approach the asymptote up here and up there. So there we go. That's what that looks like. So then it becomes a matching problem. And it's horrible because it's not even showing up. It doesn't even show the right-hand side of this. It's crazy. I feel for you. Okay, that's the last time I'm going to go through Excel. We'll just talk about it and I'll write it out in me. And you can do that. What are we on now? 28 minutes. Whew. At least you have the ability to scroll through here if you don't need to see every problem. Okay, so here's problem number 12. Use the 7-step method, and we are not going to use the 7-step method. 3x over x squared minus 16. Okay, so here's the parts that we definitely need to be able to do. We have to have a vertical asymptote. We have to have a horizontal asymptote. We have to have an x-intercept, and we have to have a y-intercept. Those are the pieces parts that we need in order to graph this. Okay, so that vertical x squared minus 16 cannot be equal to 0. So that means that x squared cannot be equal to 16. So that means that x cannot be plus or minus 4 when we square root both sides. My horizontal asymptote. Okay, So remember, that's my rules. My denominator has a larger degree. It's 2 down here and 1 up here, so the bottom is going to get much larger compared to the top. So that means it's going to approach y is equal to 0. My x-intercept, okay? So remember, my x-intercept is going to have the x-intercept is going to be my numerator equals 0. And my y-intercept is going to be the ratio of constants. So this is going to be 0 divided by negative 16, which is just going to be 0. So now what we have is we have all of the pieces parts to make this graph. Okay? In other words, we have a vertical asymptote. This one's going to be really hard. At where? Plus or minus 4. So 1, 2, 3, 4. Negative 4. So this one's going to be a unique one. It's not going to be a nice cookie cutter like the other one was, because this also has a horizontal asymptote at 0. So this actually is going to lead nicely into conducting a sign test, because that's what we're going to have. Now, granted, you can use your calculator. You're going to be able to look at the right answer and just move on, which may be what I do, but I'm going to use this chance to introduce a sign test just because I can. I know my x and my intercepts are going to be there at 0. Okay? So I do not know where to put this graph over here, but I'm going to put this in factored form. So we're going to have 3x over x plus 4, x minus 4. Okay? And the sign test is just that. I'm going to get signs. I'm going to plug in signs. Okay? For something over here to the left of negative 4. So I'm going to type in, let's use negative 6. So we're going to use x equals negative 6. And if I take 3 times negative 6, that's going to give me a negative 18. And if I take negative 6 plus 4, that's going to give me a negative 2. Negative 6 minus 4 gives me a negative 10. So this is called a sign test. Okay, because I am just worried about the sign of the number. I am not worried about the value of the number. So if I take a negative divided by a negative and a negative, that's going to give me a negative. So that means the value at negative 6 is negative in value. So that indicates that my function is going to exist down here. Okay, I've got to test in another spot. So we're going to test in the middle there. We're going to test at negative 2. That's going to give me a negative 6 to my numerator. That's going to give me a positive for negative 2 plus 4 and a negative for there. So 2 negatives and a positive is going to equal a positive. So I know here, until I get to 0, it's going to be positive. Again, I just have to continue to test this all the way through to see what this is going to land at, because I could swoop down through or I could turn. Okay, now 0 is not a double root, so I'm pretty sure it's going to swoop down through. But to test this out, we're going to test 2. So a positive 2 gives me a positive and a positive and a negative. So 2 positives and a negative give me that negative, so I do know that was for sure. I passed through. We can pass through horizontal asymptotes in the middle. And then lastly, we're going to test 6 to get me out of there. 6 is positive, positive 18, positive 10, positive 2. And so there we have it. We have all the pieces parts, and we had to do a sign test in order to make that graph. Okay, that one took way, way too long. Let's hope 13 is a little simpler. The 7-step process for 4x squared over x squared minus 4. And this is a simpler process because I'm going to have a horizontal asymptote at 4, which makes things easier. When that horizontal asymptote is 0, it's a pain. So we're going to abbreviate. We're going to go with vertical asymptote. We're going to go with horizontal asymptote. We're going to go with x-intercept. And we're going to go with y-intercept. Those are the pieces, parts we need to make this graph. Okay? Again, my vertical asymptote. If we factor this, this is 4x squared all over x plus 2, x minus 2. So we can actually, we don't have to actually solve anything. We can look at this. I'm going to have a vertical asymptote at negative 2 and another one at positive 2 because that's what causes my zeros. My horizontal asymptote is going to be, again, this coefficient because I have a degree of 2 and a degree of 2. Okay? This is a 1, so that means that we're going to have y equals 4. Okay? My x-intercept is when my numerator equals 0. 4x squared is equal to 0. So that means that x squared is equal to 0. So that means that x is equal to 0. And I know that my x-intercept is 0. My y-intercept has to be 0 as well. But here we go, it's my ratio of constants. So that means my constant in my numerator is 0, my constant in my denominator is -4, and so that ends up being 0. Okay? So now we have all the parts we need to graph this. We know we have a vertical asymptote at 2. We have a horizontal asymptote, another vertical asymptote at -2. We have a horizontal asymptote at +4. And that's what allows this problem to be so much nicer. Okay? And the fact that I know my vertical asymptote, my horizontal asymptote, my x, y intercepts are 0. So this has to do this. Okay? And I know that because there's no x-intercepts over here, it has to be up here. And since there's no x-intercepts here, my graph has to go here. So again, because of the lack of x-intercepts, I know that that is what my graph is going to look like. Okay? All right. Man, I'm getting tired of talking. We still have 4 left to go. (14) f of x is equal to -5 over x squared minus 4. Still needing the same exact things. We need a vertical asymptote, we need a horizontal asymptote, we need an x-intercept, and we need a y-intercept. Those are the parts we need. My vertical asymptote, if I go ahead and factor this, this is -5 over x plus 2, x minus 2, because we may end up with a sign test on this one. Because again, my horizontal asymptote is 0, and that's just pain. Okay? Alright, so my vertical asymptotes, x cannot be -2, x cannot be +2. My horizontal asymptote, again, we go to my rules. My denominator has a larger degree, so it's going to get larger faster. So that means we're going to always go to y equals 0. My x-intercept is kind of unique on this one. My numerator equals 0. Ouch. What does that mean? Well, this means there's no x-intercept. And my y-intercept is my ratio of constants. So my constant in the numerator is -5, -4 in my denominator. So that means it's going to be 1.25. So this one also has a little different flavor to it. Okay? Again, we had 2 vertical asymptotes, 1 and 2. A vertical asymptote +2, another one at -2. Again, this horizontal asymptote at 0 is nobody's friend. Okay? We have a y, we have a x-intercept that doesn't cross the x-axis, so that makes it unique. And up here at 1.25, we have my y-intercept. So, again, this is going to relegate us into a sign test. Okay? And the nice part is we only have to do one, and we'll talk about that in a second. So here we go. We're going to do a sign test. I'm going to test out here -4. So we're going to test -4. So we're going to roll with -5 all over. And actually, again, it's a sign test. I didn't need the 5 parts. We have a negative on top all the time. -4 plus 2 is going to give me a -2. -4 minus 2 is a -6. I have 3 negatives, which is going to give me an overall sign of negative. And we're stuck here because I'm looking at this. I've got a mistake somewhere because if I have a negative value out here, I have to get up to this y-intercept, and that's going to mean I'm going to cross that x-axis, and I know I have no x-intercepts. Somewhere I have made a mistake, and now I need to go back and see if I can figure out what that mistake is. It would be more helpful if my y-intercept was negative, but I know my y-intercept is not negative, it's positive, because it's -5 over -4. Alright, so Let's use the tools. I don't know why we're hanging up here, but we'll try it. Oh, you're an idiot. Okay. I'm going to call myself an idiot because I wasn't thinking right. We're going to approach this. I was thinking it looked like something else. So we're going to approach that asymptote just like it was. Since there's no x-intercept, we know that it's going to do this. Okay. And again, because you had your calculator, you could have done this. We have to sign test over here for a positive 4. Okay, so the top one's always going to be negative, but now I'm going to have a positive, and I'm going to have a positive as far as 4 plus 2 is 6, 4 minus 2 is 2, and we're going to end up getting a negative sign out of that, so that's why this exists down here. I feel really silly because I botched that up. Anyway, let's get 15, 16, and 17 done and get out of here. These are going to involve my slant asymptotes, I believe. Nope, graph another function. I actually am going to leave 15 alone. It's just another function. I don't think there's anything special to it. No. All right. Here we go. So I'm going to switch over to 16. The slant asymptote, we have x squared minus 25. The first slant asymptote is very hard just because it's very, very ugly looking. But we're going to divide this by x. So there's the function. So when we do this, it just wants to, no, it's the 6 parts remaining. So we're going to graph this rational function as well. Okay? So this means that we're going to have, we're going to have a vertical asymptote. We're not going to have a horizontal asymptote. We're going to have a slant asymptote. We're still going to have an x-intercept, and we're still going to have a y-intercept. Okay? My vertical asymptote there is 0. That's not too hard. My slant asymptote becomes a little bit unique because what we need to do is we need to divide to figure out what we have left, and usually we do that using synthetic division. Okay? So we're going to put a 0 in the box because that's my root. Okay? And then we're going to have a 1 followed by a 0 followed by a negative 25. 0, 1, 0, 0, 0, negative 25. So that means that if we looked at what's left over, my remainder is negative 25. My constant is 0, so that means this is an x term. So my slant asymptote is going to be y equals x, because I don't worry about the remainder at all, and that's going to be my equation, x plus 0. My x-intercept still works the same exact way. X squared minus 25 equals 0, so x squared equals 25, so that means that we get a plus or minus 5 when we square root both sides. My y-intercept is going to be my ratio of constants, and in this case it's negative 25 divided by zeros, which is undefined, so that means there's none. Alright, so this graph is not going to cross the y-axis, which makes sense, because we have a vertical asymptote at 0. Okay? Alright, let's see if we can sketch the graph of this real fast. Move on. I have one more to do. So we have a vertical asymptote at 0, so we're going to mark that vertical asymptote in here at 0. We have a horizontal asymptote. We said the equation of my horizontal asymptote was y equals x. So if we were to graph that, that means it has a y-intercept at 0. It's going to go up 1 and over 1, up 1 and over 1 again. So that means we have a slant asymptote that looks something like that. Okay? X-intercepts. We know we have one at positive 5, 1, 2, 3, 4, and 5. We know we have one at negative 5, 1, 2, 3, 4, and 5. So that means that we have all the pieces that we need. We know that's going to, from this, approach that asymptote, and it's going to approach that asymptote. These are just really, really wide. Okay, it's going to be really funny when you, I think it's a multiple choice one, so that's not too bad. Okay. All right, we're going on 45 minutes. My goodness. This will take forever to load to YouTube. Anyway, 17, let's finish it up. Again, this is going to have a vertical asymptote. That vertical asymptote is going to be x is equal to 6 because that's what causes my 0 in my denominator. This one's going to have a slant asymptote, which is what we're working on because the degree of my denominator is 1. The degree of my numerator is 2. So that means that we have to long divide that. Actually, we could long divide this. X minus 6 goes into x squared plus x minus 6. So we know this is going to be an x. X times x squared. X is x squared. X times negative 6 is a negative 6. X. We're going to change the signs because we're subtracting. So that gives me a 7x minus 6. So what times x gives me 7x, which is a 7. So that gives me a 7x minus 42. And actually, I'm done because I'm going to change the signs. Those cancel like I want to, and I don't care what my remainder is. So y equals x plus 7. All right, so we have my x-intercept. That means that x squared plus x minus 6. I need to know when does that equal 0. So if we were factoring, that's an x plus 3 and an x minus 2. We know that equals 0, so we get negative 3 and a positive 2 out of it. So those are going to be my two x-intercepts, and I have a y-intercept. My ratio of constants, negative 6 over negative 6, which is going to be 1. So now we have all of the pieces parts to make this. We have a vertical asymptote out here, 1, 2, 3, 4, 5, and 6. We have a slant asymptote which follows that line, y equals x plus 7. So 1, 2, 3, 4, 5, 6, 7, and from there it goes up 1 and over 1. Or 1, 2, 3, 4, 5, 6, and 7. I know it's going to be that way, so we could just draw this. And this is where this is going to be way off the paper. Oh my goodness. We have an x-intercept at negative 3. And another one at 2. And we have a y-intercept at 1. So again, it's nice because it has to approach that asymptote. It's going to circle around and approach that asymptote. So that was easy enough. And then we're going to have a little sliver up here where that is. All right, so that took way, 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 way longer than I anticipated.